Hello everyone. We are going to see a topic spectrometer. Spectrometer it use setting everything. First of all, know this is spectrometer is instrument meant, or we may say it is also called a device. Either you may say instrument or device. It is used to analyze the spectrum spectrum pattern of white light and the study of some monochromatic light also by using two phenomena, two devices, one prism, second grating, and by this spectrometer we are able to obtain parameters like dispersive power, power of prism or lenses, prism not lenses, wavelength, lambda of spectral line obtained in the spectrum. This is also used to determine the refractive index. Index of solid or liquid, and finally we are able to obtain angle of deviation. This spectrometer consists of basically three parts. Now let us see the three parts. Among these three parts, the first part is called collimator. See the collimator first of all. This collimator is here in it. Here is achromatic combination of convex lens used in it. Achromatic combination of convex lens L1 is here. This is a slit in it, and slit, the opening of slit is adjusted by leveling screw. Here screw is here to adjust. Source is here, but when source is ignited, this slit is behave like as a source here in this case. The distance between adjusted here in the slit. This is the first part. Now see the second part of the spectrometer, that is called prism table. In this prism table, see here, it is a round table. This round table free to move around the axis, passes from a center. It contains two vernier calipers here in it, like this. Second vernier calipers is here. It is used to note the angular rotation of the prism. The second part is called of spectrometer is prism table, and the third part is called, see carefully, telescope. Here in this telescope there is achromatic combination of convex lens, L2. With this achromatic combination is fixed here in a tube. In this tube there is containing eyepiece. This is eyepiece. Eyepiece containing convex lens on both sides, and a cross wire is fixed with it. Cross wire. This eyepiece is free to move inside it. It is closed from this side. It is free to move. The distance between lens L2 and this eyepiece can be adjusted according to the need here in it. So a spectrometer has mainly three parts. We went through that. The first one is collimator, second one is a prism table, and third one is a telescope. Here in it a general ray diagram is given. Source of light falls on achromatic combination of lens, becomes parallel. This parallel ray of light allowed to fall either are prism or grating kept on the prism table or grating table, it is also called. Here in this diagram a prism is shown. The suitable stands are here on the prism table to keep the prism or table in such a way that it should not move here and there. If in the diagram prism is given and this ray get diffracted through the prism, phenomena of dispersion takes place. V1, R1, V2, R2. After refraction, its shown moves parallel. See the colors V1, R1, V2, R2. Right? When this ray of light fall here on the achromatic combination of a convex lens here on one side of the telescope, see the ray diagram, the blue, all blue color meets at one point and all red colors combine, and the spectrum, clear cut pure spectrum is obtained through this telescope T. The detailed analysis of the spectrometer is given here in the whole lecture. Now we are going to see the adjustment of this spectrometer. In this adjustment of a spectrometer, first of all we will see the focusing of eyepiece. Here in this focusing of eyepiece, this is the first adjustment of the spectrometer. in which we are moving telescope toward towards this telescope move towards a distinct wall or any shining surface like this. Here in the diagram, see this telescope, the whole apparatus is rotated in the spectrometer and moved towards the telescope inside, weaved through the eyepiece by the experimenter. If clear image of the cross wire is seen clearly, distinctly, then it is said that we are able to focus the eyepiece. Means what is done? Through eyepiece, cross wire should be clearly, distinctly visible. The second adjustment, that is a focusing of telescope and collimator for parallel rays. After focusing of the eyepiece, now this is time to focus the telescope and collimator for parallel rays. So see very carefully here in the diagram to see the second. Here in this diagram, first of all, we are going to see telescope T, where the achromatic combination of convex lens L2 is here. It is on one side of box. Cross wire is here. In thereafter eyepiece, which can move inside or outside by arrangement here in it, in such a way that the distance between achromatic combination of lens and eyepiece can be altered. Then what is done for process is done for focusing the telescope? To focus the telescope, see very carefully. After focusing the eyepiece, this telescope is moved towards white wall, and with help of the screw through which it is moved on eyepiece moved inside and outside, the distance d is adjusted in such a way that the clear image of the white wall or circular object can be clearly seen through the telescope. If one is able to do, then it is said that the telescope is focused in it. If once focused, the distance between achromatic combination of lens and eyepiece is not allowed to alter throughout the experiment. After focusing the telescope, the telescope is moved towards the collimator. See the collimator here. The slit is here in the tube. achromatic combination of lens L1. It is the collimator C. Collimator I am representing by C here, and telescope is represented by T. In this collimator, the distance between, we are keeping very fine distance, fine slit, means the distance, the opening is kept as small as possible. Here the device screws are available to set the opening of the slit. The distance between both is kept equal to the focal length of achromatic combination of the convex lens, in such a way that when either white light or monochromatic light, where sodium light we use, when it is on, the rays, see carefully, which emits from here fall on lens L1 becomes parallel. So this device is used, this collimator is used of a spectrometer to make parallel beam of light. Now, in prism table, the position of prism is here shown. We can rotate it, it is in a circle prism table. When it's rotate, position of the prism also rotate. This parallel ray of light is allowed to fall in it, and telescope move in such a way that it can see clearly the opening of a slit through it. In that condition, when it is, the diagram is like this, parallel beam of light falls on it, and this parallel beam of light again, when after refracting reach on the achromatic combination of lens, this both combine and can be seen through the eyepiece clearly. If we are able to do this, then it is called focusing of telescope and collimator for parallel ray. The third adjustment is called leveling of prism on prism table. This leveling is done for a particular purpose. This purpose to ensure, what is ensure here? Refracting edge of prism or grating becomes parallel. Parallel to whom? Parallel to axis of rotation of prism table. See very carefully. So how it is done? See in the diagram. Let it is table on which a prism is kept. Let a parallel ray of light allowed to fall here on the prism. This parallel ray of light is coming from collimator C. This parallel ray of light, when allowed to fall here on it, right, and this ray of light refracted in their desired direction. Let prism is A, B, C. Here three leveling screw is given that adjusted in such a way that this situation is obtained, and this situation is obtained by moving the screw. We can say P, Q and R. In a level, we can use spirit level also to keep in position per right position of a prism table in a level, the prism table. Here by the spectrometer we can determine the angle of prism A by doing an experiment. So see the experiment how it is done to determine the angle of prism A. See the prism table. This is prism table. Where the prism is adjusted to make ready for the experiment. All the arrangement is made. Here on it, see the position of collimator. A part of collimator is represented here in the diagram. Collimator C. The purpose of the work of the collimator is to produce parallel ray of light. When this parallel ray of light is allowed to fall on the prism through the collimator, it get refracted from the edge AC of the prism here in this side and by edge AB on its side. Now see carefully the telescope. Now the work of telescope begin. Telescope can move on the device on 360 degree, which position is read by vernier scales V1 and V2 over the prism table with help of the reading lens. Now see the telescope position. Telescope is here, moved here. The part of telescope at position T1 is here analyzed, and reading is obtained through any one of the vernier scale, either V1 and V2 on it. Position of telescope is measured when it is able to see clear cut image of the slit of a collimator through telescope. This position is position of T1 is noted. Right? Now this telescope is moved towards this side to see the position of this ray. A part of telescope T2 is here represented here, and same work is analyzed. Adjusted and clear cut image of the slit is weaved through it, and then again position of T2 is noted. Now see carefully here in the diagram. Angle of prism is this. How it is noted? Proceed this here. It is total 2A, twice of the angle of prism. So we obtain difference in the position of telescope T1 to T2. This is equal to twice of angle of prism and half of it. 2a is angle of prism. So by this way, angle of prism is determined. Now we can obtain angle of deviation deva and minimum angle of deviation deva minimum can be measured with help of this spectrometer. So see the process through which angle of deviation deva and minimum deviation can be obtained. So see this. Let us see the prism table. Prism table, a prism is mounted, kept over prism table, right? And here in it, see, collimator is represented in short form. Collimator of telescope, and with help of this a monochromatic light allowed to fall. This is monochromatic light is sodium light. Sodium lamp is used to produce monochromatic light here, which have one frequency, single frequency, allowed to fall on prism A, B and C, right? And this ray is diffracted through prism and followed a path here. This position can be obtained by using telescope. Position of telescope here, right? Now see, this prism table are rotated and different angles. When it is rotated, what happens? Due to rotation of the prism, refracted ray refracted in various directions. Here one of the green color and another is represented through black color, and in different directions after here they get diffracted. So on moving and watching through the telescope, the angle of deviation is measured by it here in it. Now one more thing is done. What is done? In this part of experiment, the prism is not available here. In absence of prism, the telescope is moved here in a line in such a way that in the direction, in the line of monochromatic light is in that condition, move here. And clear cut image of the cross slit can be seen through the telescope at this position. Now see carefully, when prism is kept in this, The position of slit is obtained through it, and difference between these positions is known as angle of deviation, deva. So on moving the position of prism table in such a way that the angle of deviation measured by the difference of the position of T1 and T2 they are getting the difference in the position of a T1 and T2 in such a way that minimum value is obtained. Then it is called minimum value of angle of deviation, deva minimum. If it is not minimum, then it is called angle of deviation, deva. So by applying this process, we can measure angle of deviation and minimum value of angle of deviation. So this is all about spectrometer, and we can also obtain the refractive index of the material of prism by using the formula, since we know that refractive index by Snell's law. N is equal to sine A plus deva minimum by 2 total by sine A by 2. So by the experiment, the value of angle of prism and minimum angle of deviation is measured and kept in the formula, and refractive index of material of prism can be calculated. So here in whole of this lecture, we are able to obtain the value of angle of prism, minimum angle of deviation, and refractive index by the formula. This is for the topic. This topic is for spectrometer and the things can be obtained. I hope you have enjoyed with that. Thank you and have a nice day to all.